Hello, and you are watching the ECE 5780 project video for John Robe. My final project for this class was to make this robot that you're seeing here operate fully autonomously. It did that using a variety of sensors and motor controllers and embedded systems. So what you're seeing on top on that plywood panel is a LiDAR sensor and a 3D infrared depth sensor. On board in the center is an IMU, and this is the visualization that the robot is actually picking up using those onboard sensors. The framework I'm using right here is called ROS, or Robot Operating System, and it's a framework that allows you to use all of these different sensors. You put them all together along with your motor controllers and enable autonomous movement of your robot. So what I've done here is I've placed a movement goal, and now I'm disabling the cost map, which is the map that determines how valuable or how important it is or how close to obstacles you are in your environment. So that cost map is what allows for the pathfinding calculations. Now, what I'm also going over here is that was the map previous that I just disabled was the map showing obstacles, and this map is actually showing, or these points are the LiDAR points, and you can see those correspond with the obstacle detection on the map. So those LiDAR points are what we're detecting as distances. So if the robot sees anything close to it, it knows that that's an obstacle. So what I've done is I've added a 2D navigation goal, and that 2D nav goal tells the robot, or actually the algorithms and the frameworks working on this, where it wants to go. And it uses this cost map, or those red and blue color areas, to determine how to do that. So you can see that it's detected those obstacles, and now it's moved that red line appropriately. Now once everything's working, and these nav goals are set, I will enable the autonomous movement, and you'll see the robot moving around. Actually, before I do that, let me show you what this algorithm is doing. So I'm generating different nav goals, and as you can see, these nav goals are lining up, or the actual paths that the robot are wanting to take are lining up with the cost map. So now I'm going to start to enable the autonomous mode on the robot. And once I do that, then it's going to start moving around. As you can see here, it started moving. And actually, let me note real quick, you'll also see these points, or the little camera images, and that's coming from the 3D infrared sensor. And that 3D infrared sensor adds to this autonomy mode. So you can see the robot slowly making its way and moving across the ground on the map. And it's going to continue doing that until it gets to the goal. Now I'll add another disclaimer here that it's been a really tough time getting odometry and position coordination on this map working correctly, and the reason for that is I'm only using an IMU sensor for the odometry information, and that IMU sensor has a double integral before you get to actual position calculations. Even though I'm using a Kalman filter, that's not enough, so we're switching out the motors on this robot and putting encoders on the new motors so that we're going to be able to increase our odometry information. Now to end this video, I want to show what the fully autonomous run ended up looking like with a little more calibration on the odometry. And here we are. Thank you very much for watching.